Good notes. We are going to do some more triangles. We've learned two things already. What were the two things we learned? What were the two major words that we learned? Okay, incenter. That was the second thing we learned, right? And what was the first thing? Circumcenter, right? How did we find the circumcenter? What did we do to find where the circumcenter was on the triangle? Perpendicular bisectors, very good. Okay, we took the perpendicular bisectors. So we found the midpoint of all the sides, drew a perpendicular line to those midpoints, and they all met at one point, didn't they? All right, what was true about the circumcenter then? The circumcenter, that point, was equidistant from what? All the vertices, right, all the vertices, okay? All right, that was circumcenter. Then the second thing we learned was the incenter. How did we find the incenter? Drew lines. We bisected the angles, right? Right. That's bisecting the angle, right? Okay, we bisect the angles, which makes those two angles up there equal to each other. We did it to all three of the angles. They all met. They all met at the incenter. Now, what was true about that incenter? It was equidistant from the three sides, not the angles, the three sides of the triangle, okay? That was incenter. So today, we're going to do something else. But before we do this, I have to introduce a word to you, and this is called the median. Yeah, you probably heard median. You probably learned something when you were in middle school. Probably middle school when you first learned this, maybe fifth grade. I don't know. Remember, there's three words and they start with M. Yeah, what is it? Mean, median, and mode. Remember that? The mean was like the average. The mean was like the average of the numbers. What's the median? It's the actual middle number. Okay, it's the actual one in the middle of all the listed numbers. Okay, it doesn't matter like how big or small or anything. Like you don't add anything, you don't subtract anything. It's just the one that's smack in the middle. Right? That's median. So remember that it's the one that's in the middle. So when you think of geometry, mode is how many, which numbers occur the most number of times. Okay, but median is this is a little different, but it's still share some similarities with the word that we learned before. In fact, if you go out on the roads, not every road has one, but if you go to the like I-95 or you go up and down 40 or 13, they have a median. What is the median? Divides the road into two equal parts, right? In a half, right? Would you agree? That's what the median does. So that's what this is things. That's what this. I said this a thing. That's what this thing is going to do. Look, we start right here. You start at one of the vertices. It doesn't matter which one you start at because we're going to do it to all three of them. All right, let's just start up here. Actually, before we do that, where are we going to go to, do you think? This is median, so we're going to start at a vertex. We're going to draw it to the what?
Middle.
Yeah, but let's not say middle. What do we say in geometry?
Median.
Not the center. The midpoint, right. We go to the midpoint of this, all right? I'm going to ungroup this just so I can... All right, so this would be the midpoint, wouldn't it? So watch what I'm going to do. I'm going to put a little dot at the midpoint. Is that all right? And now I'm going to do that to all three sides. And come over here. That would be the midpoint right there, wouldn't it? And let's come over here. And it looks like if I scooch that over to about right there, does that look about right? Yeah? That would be the midpoint there. Okay, good. So now what I want to do is I want to draw, now I'm not going to connect them. I'm going to draw from the vertex. Okay, this is the median. This is a median in a triangle. From the vertex, where? To the midpoint of the opposite side. Everybody see that? So that right there, that yellow line, let's scooch it over just a little bit. That's close enough, who cares? Alright, so that right there is a median. It's one median. How many medians are there in a triangle? There's three of them because there's three vertices, aren't there? So let's do the other two. So let's start from this vertex and go to this midpoint. Now, what do you think? Now, remember, on those other ones that we did, they all met at the same point, didn't they? So take a wild guess. They're all going to be at the same point here. So watch, if I go here to the midpoint, check it out. Now, it's off just a little bit. You know why it's off just a little bit? Because I need to be a little bit more careful with this one. Let's scooch that over about right there. That's still not perfect, but yeah, but let's make it about right. Oh, it's too far. Pretty close. I want to get pretty close here because of something I'm going to do in a minute. That's close enough. Alright. And we'll make that yellow as well. All right, so all those yellow ones are the what of the triangle? The medians of the triangle, okay? How did we find the median? We went from the vertex to the what? To the midpoint of the opposite side. So if you wanted to, we could put little tick marks here. And you saw on that last homework you did, remember we did the circumcenter? It was the perpendicular bisector, right, of the side, so we found the midpoint there, didn't we? So they could do something like this. They could say, like, this is 3x plus 2, and this is 2x minus 5, or something like that. What would you do to those to find what x is equal to? Make them equal, because you hit the midpoint, didn't you? And you know they're equal to each other because that point right there is the midpoint. Make sense? All right. And you could also say that these two sides are equal, and you can also say that these two segments, I should say, are equal to each other. You good with that? All right. Now, just because it hits the midpoint right here, does that mean that we bisected this angle up here?
No.
No, not at all. All right, so don't be fooled into that. Just because we hit the midpoint does not mean that we bisected that angle. That was something completely different. That was the incenter, wasn't it, when we bisected the angle? This is called the median, and what do? We go from a vertex to the midpoint of the opposite side. Everybody got that? Okay. Now, remember we always had something special about that circumcenter and the incenter? Well, there's also something special about this, but this is really pretty cool. This is something that I probably wouldn't have thought of on my own, but it's absolutely true. And in fact, watch what I'm going to do. Hopefully this will work out. I'll just take this median, just because. All right, and I'll scooch it down a little bit. There's a relationship here. All right, there's a relationship between this segment. I kept that dot there, okay, because that's where the median would be, or that's where the, oh, by the way, I didn't tell you. That point right there has a special name. That point. Now, we don't call it the circumcenter. We don't call it the incenter. It has another word, and it's a different type of word. It's a centroid. Yeah, it sounds like some kind of science fiction character, right? Oh no, here come the centroids. I don't know. Right? Doesn't that sound like something? I'm not much of a sci-fi type of guy, but anyway, it sounds like that. So that point right there is called the centroid. Now, let's talk about the centroid. Okay, all I did was copy that median, put it here, kept the centroid right where it was. Now, watch what I want to do. I'm going to do this. I'm going to find the length of this little segment right here. So let's start right there and scooch that down to there. Would you agree that's the same length? Or pretty close to it? And we'll do that. All right, so that length is the same as this length right here. Now watch what I want to do. I'm going to take this length here, and I'm going to put it, it's a little crooked, but you'll get the basic idea, okay? So would you agree that length is the same as this short length right here? Now what do you think is going to happen here? For the whole thing, right? Yeah, absolutely. Watch. Well, this will fit twice. This will fit twice right there. Now it's off a little bit. It's slanted a little bit, but you get the idea, right? So look at this. This short one is how much of this longer one? It's, well, of just the longer one, just this part from here to here. This is half of this, right? Would you agree? Okay, this one right here is half the whole thing. What about from here to here? That's double the short one, right? So the short one is half of the longer one, right? Or you could say the longer one is double the shorter one. But, George, you said something. You said what? Fits it 3 times. Okay, look at this. So there's another one right there. See that? So I tell you what, let's make them different colors. Make that green. Actually, it doesn't show up very well, does it? Let's not make this one green. It looks too much like yellow. Blue. Okay. There we go. See the blue one, the purple one, and the red one? All right, there's 3 of them, and they all make that same length right there. Do you see that? So one of these is what? How much of the whole entire thing? 1/3 of it, right? And 2 of them would be what? 2/3 of the whole thing. Would you agree? What if I took one and I put it right next to the other one? Then that's twice as big as this one. Agree? All right, because there's 2 of them here, there's 1 of them here, and they're all the same length. Does that make sense? Okay, with all that said, let's go back up to this picture, and that's really going to help us out a little bit. Let's get rid of this arrow and stuff. Okay? Let's just stick a number in here. Let's say that this was 3. from here, let's put some letters in here. We'll go ABC, and we'll go D, E, F, and we'll go G right there. Okay? Now let's think about this. What we just did. I did that for a reason. And it's pretty cool to have this program because I can, I can actually measure stuff out fairly accurately. If I did this on the whiteboard, it probably wouldn't be near as accurate. So it's kind of cool that we saw that this from A to G is twice as big as it is from G to F. So if I told you that GF was 3, what would you say that AG would be equal to? It would be 6. It's pretty easy, isn't it? And what's the whole thing then? What's AF? It's 9. Everybody got that? So you could keep on going. Watch. You could say, let's say, I'm just making these up, but let's say GE was 5. What would BG be equal to?
10.
It would be 10. Make sense? What if I said this? What if I said that GC was 16? From G to C was 16. Then DG would be what? It would be 8. How do you know which one's the longer one, which one's the shorter one? Well, you can kind of tell. But what if, there are sometimes, though, some people get confused and they're like, I can't really tell. Which one is the longest one? It's always from the where? From the vertex to the centroid. Everybody see that? So the one that goes from the vertex to the centroid is always the longer one. Because sometimes they draw it, they'll draw a picture, and it's hard to tell exactly which one's, even though one's twice as big as the other one, they may not draw it exactly to scale. All right? So from the vertex to the centroid is twice as big as the rest of it. You got it? Or you could say this. You could say from C to G is 2/3 of the whole entire thing, isn't it? Right? Remember we broke it into thirds? So it's 2/3 of the whole thing. Or you could say from D to G, DG is what? 1/3 of the whole entire thing. Or you could say DG is half of GC, couldn't you? Does that make sense? Okay. Let's make one a little bit tougher. Let's get rid of all these numbers. Didn't I ask you not to pop the gum anymore? Let's do this. Let's say that this right there was let's say 30. Okay, so BE is 30. And I want you to find BG, and I want you to find GE. What do you think the easiest one would be to find? Find GE. By 3, that's right, because remember we broke this down into 3 parts, didn't we? So this little bit right here is 1/3 of the whole entire thing. So if I know the whole entire thing is 30, then what's this little bit right here? It's 30 what? What's the math you did? Divided by 3. Everybody see that? Because 1/3 is the same as dividing by 3, isn't it? All right, so 30 divided by 3 is what? 10. So GE is 10. Now, BG should be easy to find. What's BG? It's 20, right? Because this is twice as long as this one right here. So if this is 10, this has to be 20. Does that make sense? Am I getting it? Now, you know what they're going to do. They're not going to make it quite that easy, though, are they? What do you think they're going to put in here for you to find? X's, right? Like 3x plus 2 and 2x minus 4 or something like that, right? And you got to figure out. But as long as you know the relationships, as long as you know that this one right here, BG, is twice as big as this one right here, GE, then you're good to go, right? Also, the shorter one is 1/3 of the whole entire thing. That's very helpful as well, okay? So that's the kind of stuff that you're going to have to do. Does it make sense? So wow, who would have ever thought that was true about something like that? Not me. I would have never figured it out myself. But now that we see it, you're like, okay, now I see it, right? And it's kind of cool with the program where I can show you exactly that, yeah, this is twice as big, or sorry, that this big one right here is twice as big as this, or this, it takes 2 of these to make 1 of these, right? Okay. Everybody got it? All right. We got one more triangle to talk about. Now, all 3 of these triangles have had something special about them, right? The circumcenter was equidistant from the vertices. The incenter was equidistant from the sides. The centroid is the one with the 2/3, right? One is 1/3, the other is 2/3. Okay, that's the centroid. Now, this next thing we're going to do, There's really nothing special about it. The only thing special about it is that all the lines meet at one point, just like all the other things do. So what we're going to do here is we are going to talk about an altitude. Altitude. We might have talked about an altitude earlier in the year. I think we did. Do you remember this? Here's the ground. Remember I drew my cool looking airplane? Anybody remember this? And then the pilot gets on there with his pilot voice. Oh, ladies and gentlemen, we're going 30,000 feet. Right? They always talk like that, don't they? They try to act like radio disc jockeys or something. Anybody been on a plane? Hear a pilot do that? So watch. If they ask for the altitude, what is the altitude? Is it like from where you are to where you're going to go? No.
How far you up are in the sky.
Okay, how far you up are in the sky. So talk geometry then. Perpendicular to the ground. That's right. It's the perpendicular distance, isn't it? That's altitude. So what if I was going to draw an altitude on this triangle? I'm going to start at a vertex again. And where am I going to draw it? Am I going to go to the midpoint? Am I trying to bisect it? I'm going, let's not say straight down. Come on. I want to go perpendicular. Okay, that's what I wanted to say. I want to go perpendicular to the opposite side. So that yellow line right there is an altitude. Everybody got it? Let's draw the other altitudes. Watch this. Let's draw an altitude. Now, what am I looking? Am I going to the midpoint necessarily? No, I'm going to a spot where it looks like it's what? It's perpendicular, where it makes a 90-degree angle. That looks fairly close. All right, so that's perpendicular. Agreed? I got to do one more. So I go from this vertex, and I go perpendicular. Guess what? Is it going to be down here? Is it going to be way up here? What do you think it hits? It goes through what? It goes through that point right there. Exactly right. We call them concurrent lines. Do you remember that word? Anytime three or more lines intersect at the same point, we call them concurrent lines. We call this the point of concurrency. All right? That's a very general statement. This has a fancy name too. So let's go through our fancy names so far. What was the first fancy name?
That's the central.
Circumcenter. Then the second one was in-center. Then the first one we learned today was the centroid. Now this has got a real crazy name to it. I don't know where they get these names. Well, I know where they got median, right, and all that. But this, I don't know. They call this an Ortho Center. Ortho Center. There you go. Ortho Center. Well, how did you find the Ortho Center? What'd you do? You drew the what? You drew the altitudes. And what is an altitude? It's perpendicular, right? It goes from a vertex perpendicular to the other side. That's different from the circumcenter. How did we find the circumcenter? We did the perpendicular what? Bisectors. That's right. So we took the midpoint here and we drew a straight line up and down here, didn't we? A perpendicular line to it. Didn't necessarily go through the vertex. Everybody understand that? But on the altitude, you start at a vertex and you go perpendicular to the opposite side. And it meets at a point right here. You know how a circumcenter had something special about it? So did an in-center, so did a centroid. Well, guess what? You're not guessing. Guess what? All right. Yeah, I kind of led you into a trap. So you probably think there's something special about this point right here, didn't you?
No.
But there's not. Okay, there's not. It's not equidistant from anything. It's not 2/3 of anything. It doesn't, there's nothing special about that point. The only thing special is that they all meet at one point. So the Ortho Center is really not that big of a deal, to tell you the truth. It's the other three that are really the big deals. Everybody got that? All right, so there's really nothing special about the Ortho Center. But it is kind of cool that they do meet, all right, at one point. All right. Actually, the Ortho Center is kind of cool, to tell you the truth. Let me see something here. I think it's the Ortho Center.
Ortho.
All right, stop. No, is that the? Maybe it's the centroid. I think it's the centroid. I don't know. Let me see. Let me pause this.